Hello all. Welcome to Mixed Reality Production Tech Talks. All your SIGGRAPH so far? Good? Yes? I will begin. I'm David Hurtubise, Technical Account Manager at Epic Game for the East Coast on the media and entertainment, so working with Moment Factory and other kind of business like that. I do media and entertainment, animation techniques, Mocap and tracking, and real-time performance using live techniques. I worked in 2015 on the integration of Oculus and Optitrack into Unreal Engine with the SIGGRAPH. It was a government agency. And I'm doing a master degree at University of Quebec in Chicoutimi and the NAD Center on pervasive computing. So, I want to talk to something. What's the term LBE mean? If I tell you about LBE, do you know what that means? So LBE is the acronym for location-based entertainment. It's especially, especially the term applied for a virtual environment with a multiplayer experience. So it's in recent year, the integration of virtual reality into LBE has become increasingly popular. With multi-million-dollar investment, the introduction of virtual reality experience in theme parks are booming. So this is why I want to talk a bit more with using Unreal Engine in the LBE attraction. So back to the days, I think the best example of LBE was Star Trek with holodeck. After that, there are some well-known examples of companies that specialize in using LBE attractions. In 2015, a mixed reality experience called The Void was born. So it has become a benchmark in the LBE field. The experiment is described as follows. A user wears a VR headset, Optitrack trackers, manual tracking sensors, haptic combination with 22 sensors, backpack computers to power the headsets. It was kind of a 101 for the real and virtual space. Really nice experience. Subsequently, several projects have emerged. So in this line, I will present two projects that have been made with the Unreal Engine and our customers. First, Hologate. It's a thematic attraction offering a virtual reality multiplayer experience with HTC Vive. So here's the video. Okay, so it's a VR environment using 270 square feet, multiplayer game that can accommodate up to 4 players with HTC Vive, touchscreen interface, interactive LED lights. So you have the options to choose between different video games. You can communicate with your friends, that can hide for covers, fight robots and zombies, things like that. So The VR system has grown fast in their history with a fast and compact solution, but as they were aware of some important LB issues, Olegate was created to the minding of improving these elements. So they improved those the space requirements, cost involved for the hardware, the maintenance, difficulties to set up, the knowledge beyond that, and the kind of the thing that we don't have social contact. So following the discussion, we talked about the issues like using the right avatar for LB games. Replication of an avatar in VR is still very experimental. Because problem set for is to set a fast user calibration automation, which will work on multi-user. So if it's not done properly, they have some offsets on the avatar via your body, so it adds the sensation of disbelief. Whoops, sorry. I will talk more in the third section about a solution to manage that with IKINEMA solution, and we go further to make a 4D of the OF point to track to retarget the IK. So the second thing, the second experience is Jake Part 1 by Baobab Studio and director Matthias Schelsborg. It was the most popular attraction in Tribeca Film Festival VR Arcade, combining immersive theater with virtual reality, real actor, and animations. So I will show you the video. So it used the Optitrack tracking technology. I will talk a bit about that later. They use HP backpack, 28 cameras, Optitrack capture systems, leap motions for the player, the IKINEMA map Mocap solution, and IK retargeting for the actor, and in a space of 10 meters by 7 meters, they're using the Manus VR. And dynamics to make the facial tracking. So one of the issues that it related to that is to manage all the third party all together in one system. So we'll go more further on that after. What's special on this experience is that everything that people can touch can be experienced. So when you put your hands on the woods, it is woods. Put on the ovens, it can burn yourself. They use Arduinos to sequence some things like using when you leave the house, there's a flurry of fresh air and things like that. So with the issues, Jake have some issues combining the third party together. They had issues to have zero latency using the Wi-Fi too. So and they mix Optitrack Translation and Oculus Rotation to make the head tracking really nicely. So this is for Jake 1 experience. I want to show you how to create LB projects now. So funny things, little historical anecdote, but back in 1975, the Event Sutherland defined the general functioning of ultimate VR systems. It was kind of really early, but it was functioning. So yeah. I will show a little the information about the technologies. It's in relation with the demo that we do with Normal Studio and Lemuel Pilon for the art in Montreal. We'll use Optitrack motion capture system, HP ZVR backpack, the IKINEMA solution, lights, and Arduinos. We use 8 prime 13 cameras and 20 by 20 feet space. It's not really big, but for the demo purpose, it was okay. But if you want to go on production, sure, you will have to have the double of cameras than we have. The issue related to LBE, there are 3 main gaps identified in the current LBE virtual experiments described above. The restricted space for displacement, the accuracy of tracking objects, and the absence of the body. So we'll go through those issues according to the steps, creating a multiplayer game using Optitrack, optimizing the HMD, and the real-world component, and solving Mocap and retargeting using IKINEMA. So before going further, I just want to say talk about what's new in the 4.20. You have the HD SDI video and audio input-output with the AJA card, so Corvid for 4, Kona for cards. You have full support for key and fill. You have the timecode, LTC, VITC now, the Genlock. You have multi-display with the end display. You will be able, if you have like a LED screen to manage, you will be able to output on multi-display. You have, as you said, maybe yesterday on the demo for Unreal, the multi-user experience. You can work together on multi-PC. You have now the Niagara Visual Effects editor. So it's an update of Cascade. And you have the exporting summit output for the audio. That's nice. For AR, you have the Apple AR Toolkit support now 2.0. Google AR Core 2 for support. So step 1, creating a multiplayer game using Optitrack. We'll use Motive as the software. So using Motive, yeah, I just want to take my, can I go out? There we go. So we'll use this software with Optitrack to manage the data from the rigid bodies to Unreal with the plugin. So Motive can stream data from rigid body to 3D skeleton. Rigid bodies defined to use at least 3 points or more trackers in the environment. It recommends to have at least 5 points to make something nicely. So in Motive, you just have to select the you select the point, and then you create right-click. You create the selected marker. With the selected marker, you create the rigid body. That will give you a rigid body with a streaming ID that you will be able to manage. The ID will be able to be managed in Unreal. So you can download the plugin here. The Optitrack have uploaded the 4.19 plugin, but it has the source code for rigid body streaming, skeleton streaming. So you'll be able to compile to 4.20 easily. And I will talk after about using 4 degree of freedom called DOF, using rigid bodies to make an avatar. So using rigid bodies on the back, on the head for the HMD, and the ends, and doing a retargeting IK with that. So one specific point is about the pivot point on the Motive. So to have a nice pivot point position and orientation in Unreal, you need to create with the HMD. You will need to manually carefully adjust the tracking, the pivot point. So with the move and rotation tool. You will need to manage the pivot point and place it to the bridge of the nose, basically right at the midpoint between two eyes, like you did, like you have in the real world. Oops, not on that. This is really important to remove the offsets that you will have maybe during the game when you will use the translation and the rotation of the head. So we'll use a multiplayer template based on the template tutorial, the local multiplayer tutorial that been used, that can be find on this YouTube channel. It's from Unreal. So with that, we'll need some optimization for the Optitrack. You will use the dedicated server, but we'll need to use more a more complex sender to manage the Optitrack. So, quick tip: if you want to debug using the command prompt and send the server and the game on your computer, you need to. For the server, you go to search the Unreal Engine editor and the editor location. You go search after your Unreal Engine and the map use dash server dash log, and you will be able to shoot the server. And after, for the game client, you need to get the editor location, the U projects. And it's really important to take the same project version as the server work if you want to have all this together workings. And you add the server IP address and dash game dash log, and you will be able to manage on different computers a debug mode, and you don't have to compile your game. For Optitrack, normally a dedicated server is based on that. So you have the server, you send it to the client. For Optitrack, you need to have the both side, like an hybrid solutions. You will have to send the Optitrack data to the clients, but on a specific way. So some notes: the game mode only exists on the server. Replication work from server to client, and you will need Optitrack client origin class on each client. So to do that, first, you have to define a class for the Optitrack. Normally, Optitrack have this class already that you can take. Whoop, sorry, not my good one. Okay. Normally, you have the client origin already on the class that you can use. You will need to use, using the blueprint class, custom class. So you go take in the custom class down the origin Optitrack origin client class to create a specific client for each client. And on that, you will have to manage the server address and each client address that you will have. Keep note that you will need to use unicast. I propose unicast is better solution than multicast. And IKINEMA work better on unicast. Dedicated data server use it too. So mostly it defines many issues with that. So after that, I'm using all the multiplayer template defined on post login in the game mode. You will have to define in the player controller a specific class that a specific function that will send the data. So you will spawn the Optitrack things using each player number, and you will be able to define to spawn a specific class using air. Keep note also that you need to check for replication, as we need to replicate the data. So to add UE4 commands to events on the sequencer or real object like Arduinos, you need to good understanding of that. So the events replication is set with custom events. I don't know if you are familiar with that, but if you need to send send replications commands, you'll need to always use custom events, and in the custom event in the graph, you'll be able to replicate on multicast, server, or clients. You will have to, if you need to use a class on replication, use on the class default. You have the replication and all the relevant replication information that you need to manage to make it works, as the movement and things like that. Same for the variables. So if you put the variables, you will have replication error. So all this needs to be added. For so we need to adjust the pounds with the Optitrack informations. So to get the data from Optitrack, I will show you. It's a unique component, Optitrack rigid body components that you will add on your blueprint or on your on specific static mesh or skeletal mesh. So using it, so you find it here, and you have in this class a tracking ID that will use depends of your motive rigid body ID down there. So I want to take this one. I will put 1 to the tracking ID, and I will send. Keep note that the rigid body needs to have a child component. So I will add a static mesh. It's a nice thing to have to say how it works, to see how it works. So I will add it like that. So 1, okay. And you need to add the Optitrack client origin. It's not defined by default, so if you want to manage something not using the multiplayer system, you will need to add the Optitrack client origin already. So I put it on on my server and client address on the loop. Put the motive informations on edit, and on data streaming panel. You'll have to put active on. Oops, sorry. Where? Broad frame data on. Loop back, as I do a loop back. And those information, Y up is really important. And unicast. And I will play. There you go. And you will have that moving. There you go. So you can use already with the static mesh, or you go take this information if you want to manage the different point as the HMD point or things like that. So you can get the class of this. So new blueprint 1. And for each loop, I will get the Optitrack rigid body. Oh. Sorry. And get the well transform or location, and set the well location of this. So you will be able to manage the same thing using that. Okay. You will need to improve your HMD informations. So in performance consideration, I add you have some nice place to check for Oculus best practices. So the Oculus forum, VR documentation, the VR subforum, and you can find here I put some nice tips to manage the Oculus optimization. So on the controller, the player controller, you'll be able to manage settings for the Oculus and add commands specific like the res, HD res, 3000 for the pull size, screen percentage to 130, pixel density to 1, anti-aliasing quality, the bloom quality, removed, things like that. So as the project will be VR and especially on backpack and Wi-Fi, you need to disable every post processes. So like bloom, ambient occlusion, you'll need to revisit traditional constraint, look at your scene complexity like particles, dynamic shadows, smoke effects, polycount mesh, and minimize overdraws to keep performance at the maximum. So the cool part to connecting Arduinos, for this game, I don't know if you know the Arduinos things, but Arduinos are little motors, little relay that you can plug on USB connections. You will find the link of the plugins here. You use the Arduino IDE software that you can find there with the plugin, the link. So to connecting the Arduinos, you need to open the port, and you will branch it. So on that, we need to use the level blueprint and set the Arduino's here. So Arduino's, you open the serial port as you will define in your code in the Arduino's software, and you will set a write byte for your specific event, and you will remove the byte after. So just like input output, it's work with some two values will work to make it happens or close. For the ArtNet, we have a nice solution with the LightTac plugins. LightTac is a media server software. It can generate playback pre-rendered content, so it modified in real time based on a variety of different inputs and send it to video or lighting outputs. So to set ArtNet, you go to, you will have first in the ArtNet plugin, the ArtNet, the LightTac, sorry, software here. You will need to define the device. So between Unreal and the LightTac solution, it's shared memories. It works with the shared memories. So you take a Jensen memory reader, just put the right data, and you will be able to manage the information from an Unreal Engine. So in the data, with the right shared memory and the specific infos, you will be able to manage the right data and send the variables that you want. If I check, it's 10. It's got to 0. So you manage information from shared memory. And like that can be used to create fixtures. So after that, you will be able to use this to manage your ArtNet fixtures. And you can use MIDI to use to manage MIDI information for the lights, or MIDI to the MX interface. So you have to use software like MIDI Aux to manage it well. So you need a combination of MIDI and DMX interface with that. Suggest to use Sunlight Suite. It can be used very well for that. So it manages DMX to USB hardware. You're able to map DMX to MIDI controller to send the data to Unreal in the MIDI signal. So you find a device and and you break the device to find. I will show you. It will work to under-level blueprint. So you find the device, find the ID, set the controller, bind it to an event, and you'll have the channel, control ID, velocity, and all this kind of stuff that you can put in an event to manage the MIDI inputs. For MIDI output, you can make a loop with those, so it will work too. Okay, step 3, solving mocap and retargeting using IKINEMA. So large social focus companies go even further with the representation of the upper body and or the whole body. So here's the IKINEMA solutions. First, you need to record mocap pose using Motif from Optitrack. A good way to help you correct the live mocap is to set a series of ROMs. It's a range of motions. It will help you correct some specific poses in Unreal. So you can start with that record series. Propose that, but it's nice to begin. So T-pose, A-pose, squat, square reach, hips, torso twist, roll shoulder, arm stretch, head rotation, ends to end, and back to T-pose. With that, you will have a nice record to manage your solving. So to make it work with IKINEMA, we'll use, in that case, we have four rigid bodies. So first step is to import your FBX data in the engine. So when you import it, it's really important to set it to, as for rigid bodies specifically, to set a really small range of playback. Don't put it to stop; it don't work. Do a playback and on the T-pose and loop it, and you will be able to manage the connections. So in the Unreal Engine, you will import your mesh. You can import TOS reference pose to manage the pose if you don't have the character directly in T-pose, but you will need to have the character in T-pose too from your DCC. So after you create the IKINEMA rig. So you go to create IKINEMA rig. Yeah, and we'll need to do a little bit of cleanup. So you delete all the unized bones, carpals, phalange, dorsal, skid joint, face and air, and twist. Once you've done that, you need to output the command log to make IKINEMA working with unicast. So you put a.use unicast space 1. You set the mocap source, Y up, the server address. Streaming Y up is really important. don't click the 0 source. You need to put the scaling to 105 or near 100. The scaling part is try and error thing. You need to validate the size of your avatar between the size of your actor. You will change the import scale in order to match the avatar. So you import like that. So you click import. So you will have your rigid bodies down there, like that. The second step is to match the rigid bodies with the character. So you will need to set up nicely a base accuracy for the nice matching of that. So you rise up the shoulders. So you place the arm rotated to the right place. Make sure it bends in the elbows and knees. And so go to the mapping editor. And set the rigid bodies for the bones, specific bones that you use. After that, you will need to connect the specific joint, the bones to the rigid bodies. For that, you right-click on the joint and press link joint. You create the task. You you will create the task for the pelvis, the spine, the head, and the ends, as we need that. So hips, chest, ends, head, and ends. And after that, in an animation blueprint done for the character, you will manage the Mocap stream as you do actually with the IKINEMA using the server name, the specific node that IKINEMA use. So you manage all the same information that you put on the IKINEMA rig. Use the retargeting IKINEMA rig that you have done. And what's specific with the rigid body is that you need to put the rigid body downstairs, the button you need to click on, and you need to add the specific actor that would be linked with your IKINEMA rig. And there we go. So as we don't have all the down informations, we need to close. We need to split it with the blend layer per bones to have an automatic animation with that. So to have a nice looking with that, you will need to go deeper and deal with specific things like the weights. The weight is in IKINEMA is inversely proportional to stiffness. So the lower the weight, the greater the stiffness. You lower the weight to a very small value. A quick tip: if you don't know what to put, always go to 0.5. It's a safe bet. So yep, sorry. So we had the okay, just one moment. Okay, important part rely on the ends. So you will have to retarget gains to use the retargeting gains. They have 3 stages, 3 multipliers. So you have the first one, like it's global retargeting gains that be used on every bones. You have the second per bones as a multiplier for the solver target, and the third multiplier is per axis. So we'll use a combination of that. Minimize the gain of rotation for the ends using the axis multiplier. So it's not very good to have a very heavy settings on the arms. It interacts badly with the shoulder and torso. So we had the Y and Z retargeting gain like at 0.1 for that. We had some stiffness on the shoulder, like less weight along twist axis at 0.2, 0.3, and 0.3. Like that. And we had the stiffness to the neck also. So it will be much better, and the IKINEMA, the IK will be really nicely. About the scaling, as it's a kind of a big problem in the okay. In the case of scaling, between different persons, you have two things to worry about. In order to match the avatar to the real world with real scale from Optitrack, you have to calculate 100 divided by the import scale of the actor. So in that case, it's 105. So it gives you 0.95. So you put it to the avatars on the setup, on the avatar you have put on the level. So the second one is set the import scale value in the in details panels in the anim blueprint. So using the Mocap node to the right value. So it imports scales mean the filing. So you set the import scales to the specific information that you need, depends to different people. The new release of the IKINEMA will have an import scale as a pin, so you will be able to manage logic about it. So don't forget, it's a ratio between Unreal and Optitrack to keep in mind. So for the lower part, as I said, it was kind of working really weirdly, but you can you use the final pose, so you layer the blend by pose with that. So you put the layer blend by pose to manage all the bounds that will be done. So future of FLBE, the future of virtual reality and location-based entertainment looks bright. There are already many different opportunities available for immersive technologies. Many companies are investing large sum of money into opening a new location. So some statistics from Tractica that estimate that the amusement sector will be the most important category for the enterprise. So VR hardware and content 2021. So there's kind of nice informations. So as you can see, the Unreal engines became more and more using in theme parks, rides, VR arcade experience, arts installation, many other places. And it's only a quick overview of what it has been done with Unreal Engine team and those projects. So you can go look further on complete video and YouTube for information. So there's where we are. Send special thanks to those peoples. And that's all the time I have. Thank you for watching. If you have questions.